Renewable energy is energy that comes from natural resources such as wind, sunlight, rain or water, tides, geothermal heat, and biomasses. Renewable energy can be converted into electrical power, mechanical power, or thermal energy. The most commonly used renewable energy resources are hydropower, wind, solar, and geothermal. Hydropower, hydraulic power, or water power is power that is derived from the force or energy of moving water, which may be harnessed for useful purposes. Hydropower can be used for the generation of electricity, for irrigation, and operations of various machines such as water mills, textile machines, sawmills, dock cranes, and domestic lifts. Conventional hydroelectric refers to hydroelectric dams. Run-of-the-river hydroelectricity captures the kinetic energy in rivers or streams without the use of dams. Pumped storage hydroelectricity is pumping up water and using its head to generate in times of demand. Tidal power captures energy from the tides in horizontal direction. Tidal stream power uses stream generators somewhat similar to that of a wind turbine. Tidal barrage power uses a tidal dam. Dynamic tidal power utilizes large areas to generate head. Wind power is the conversion of wind energy into a useful form of energy, such as using wind turbines to make electricity or windmills for mechanical power. There are two main types of wind turbines, vertical axis and horizontal axis. Wind turbines convert the kinetic energy from the wind into mechanical energy. The mechanical energy can be used to produce AC electricity. The horizontal axis wind turbine is the most common type of turbine used when producing electrical energy. There are two types of horizontal axis wind turbine, upwind and downwind. Upwind are the most common since the blades are positioned upwind of the supporting tower. Downwind turbines have been built, however there's a problem of turbulence created from the supporting tower which decreases the efficiency. The horizontal axis wind turbine has a main rotor shaft and electrical generator at the top of a tower and must be pointed into the wind. This is typically achieved by use of a wind sensor and servo motor. Large horizontal axis wind turbines have variable pitch blades that can change the pitch of the blades to control the rotation speed of the rotor shaft. Turbines used in wind farms for commercial production of electric power are usually upwind three-bladed turbines. Solar energy is the conversion of sunlight into electrical power or thermal energy. Electrical power can be directly generated by the use of photovoltaics or indirectly using concentrated solar power. Photovoltaic materials are used to convert sunlight into DC electricity. The photons of light come in contact with the photovoltaic cell and knock the electrons into a higher state of energy to create electricity. There are many different types of photovoltaic materials. Materials presently used for photovoltaics include monocrystalline silicon, polycrystalline silicon, amorphous silicon, and cadmium telluride. Since the photovoltaic materials are susceptible to damage by weather, they are packaged tightly behind an anti-glare glass sheet. When more power is required than a single cell can deliver, cells are electrically connected together to form modules or panels. Multiple modules must be connected to form arrays to provide enough power for a house. Generally, temperatures above room temperature reduce the performance of photovoltaic cells. For best performance, terrestrial photovoltaic systems aim to maximize the time they face the sun. Solar trackers achieve this by moving the photovoltaic panels to follow the sun. The increase in efficiency can be as much as 20% in winter and 50% in summer. Concentrated solar power systems use lenses or mirrors and tracking systems to focus a large area of sunlight into a small beam. Solar thermal technologies can be used for water heating, space cooling, and process heat generation. Geothermal energy is thermal energy generated and stored in the earth. Thermal energy is energy that determines the temperature of matter. Earth's geothermal energy originates from the original formation of the planet, from radioactive decay of materials, from volcanic activity, and from solar energy absorbed at the surface. The geothermal gradient is the difference in temperature between the core of the planet and its surface. The geothermal gradient drives a continuous conduction of thermal energy in the form of heat from the core to the surface. Geothermal power can be used to produce electricity, or it can be used in direct applications. Electricity production is achieved by the use of heat engines and is typically done on a commercial scale in large power plants. Direct use applications are generally used for district heating, greenhouses, fisheries, mineral recovery, and industrial process heating. Geothermal electric plants were traditionally built exclusively on the edges of tectonic plates where high-temperature geothermal resources are available near the surface. The development of binary cycle power plants and improvements in drilling and extraction technology enable enhanced geothermal systems over a much greater geographical range. There are three basic types of electric power plants: dry steam, flash steam, and binary cycle. Geothermal heating relies on an energy exchange between the air within the building being heated and the ground. Below 10 feet, the Earth's temperature is fairly constant, generally between 50 and 56 degrees Fahrenheit. During the summer, when the ambient temperature of the building exceeds that of the ground, heat pumps are used to pump heat from the building into a transfer medium, typically water with small amounts of ethanol or glycol. The heat is subsequently pumped through narrow pipes into the ground so that the heat can be dissipated in the earth. When the ambient temperature falls below the ground temperature, the process works in reverse. Heat pumps extract heat from the ground and use it to heat the building. Biomass is biological material from living or recently living organisms such as wood, waste, gas, and alcohol fuels. Biomass is commonly plant matter grown to generate electricity or produce heat. The most conventional way in which biomass is used is by direct incineration. Forest residues, yard clippings, wood chips, and garbage are often used for this. Biomass also includes plant or animal matter used for production of fibers or chemicals. Biomass may also include biodegradable waste that can be burned as fuel. It excludes such organic materials as fossil fuels, which have been transformed by geological processes into substances such as coal or petroleum. Biomass energy is derived from 5 distinct energy sources: garbage, wood, waste, landfill gases, and alcohol fuels. There are 3 processes for biomass conversion. Thermal conversion is the process in which heat is the dominant mechanism to convert the biomass into another chemical form. Chemical conversion relies on a range of chemical processes that may be used to convert biomasses into other forms, such as to produce a fuel that is more conveniently used, transported, or stored, or to exploit some property of the process itself. Biochemical conversion. A biomass is a natural material. Many highly efficient biochemical processes have developed in nature to break down the molecules of which biomass is composed, and many of these biochemical conversion processes can be harnessed. Wave power is the transport of energy by ocean surface waves and the capture of that energy to do useful work. For example, wave power can be used for electricity generation, water desalination, or the pumping of water. Electrical applications for renewable energy include residential, such as grid interactive or off-grid remote power, commercial, such as power plants or backup power, and mobile, such as marine, vehicle power, and space.